Hi, my name is Riku Viri, and I'm here to talk about a smarter public transport network. So to start, we actually collect and generate a lot of data, whether that's public transport related. We know where the buses are, where they are heading, what type of timetables they have, all that kind of stuff. From other road users, we know the congestion levels, queue lengths in all of the junctions in the city. We know whether there is roadwork somewhere, whether there is some type of accident or some other service disruption that will actually change on how the networks work. So whether there is more traffic or less traffic than usual in some areas. On top of that, we know something about the passengers. We know the number of them. We get a rough idea of something. We know how they check into the buses. We can have some kind of capacity estimates for the tram, for example. We can estimate a lot more. We know whether there's some kind of emergencies in place, whether there is, let's say, an event that gathers a lot of people. So we have a lot of data. And that type of data has been used, I'd say, mostly to actually make the user experience better. But what we could actually use that to make the network better. So if we use some kind of AI solution that can detect different type of patterns, whether there is, let's say there is service disruption somewhere, it will lead to more passengers somewhere else. Whether there is large gathering at the arena, there will be more passengers. There may be some people that tend to drive the same journeys every day, which we can learn from the smart card data. So I'm not saying that we are able to forecast entirely what will happen from the next days based on all that data, but we can find some kind of patterns on what happens and what doesn't happen. Or we can at least know that if this happens, this is the most probable thing that follows it. There has also been a lot of these autonomous vehicles in testing here in Hervanta as well, and those are highly better scalable than, for example, regular driver-operated buses. So what if we can combine that type of data and AI pattern detection to actually build a network that instead of having that type of rush hour, if there is some kind of large gathering at the arena, a lot of people, bad weather, why not have 2 more buses in the fleet? Or if it's nice weather, not that much going on, maybe remove a few buses. Can we make that kind of demand-driven network? I think we can, but there is that question mark as well. It's not that easy, and I'm happy to discuss also the challenges after this. Thanks.